Right, so in this video, this Zoom lesson, we're going to talk about solving trig equations. So it should say trig in the title, but solving equations that have like sine, cosine, tangent in them. All right, so there's different types of these. So for this first lesson, it's kind of the more straightforward ones. There's only going to be one trig function in the equation. So our steps are going to be to isolate the trig function and then use an inverse operation. And be mindful of the intervals of the angles that we have to solve for. So if it says that x has to be in between 0 and 2 pi, right? We want to find all the angles between 0 and 2 pi. If it's written like that, you want to answer in radians. If it says all the angles between 0 and 360, you want to answer in degrees. And if it doesn't say, then you have to list all possible angles, which there's usually going to be an infinite amount. And I'll show you how you can express that. All right, so if there's no intervals given, assume they're infinite solutions. All right, so use a calculator to solve the equations on the given intervals. Now, by use a calculator, I should specify like use a scientific calculator. So I'll show you how to do it all by hand, and then you need a calculator to figure out what the angles are. Or you could have a calculator just solve this if you have a TI-inspired CAS. And if you want decimal answers, you can also just graph both sides. So I'll show you all the ways. All right, so first way is solving it mostly by hand. All right, we want to isolate this trig expression. So I'm going to add 7 to both sides to start. All right, and I get -3. All right, then I'm going to divide both sides by 4. And I get that the sine of x plus pi over 5 is equal to -3/4. All right, now in order to get what we're trying to solve out of the sine function, we need to use an inverse operation. All right, you can't divide both sides by sine because sine is a function of an angle, but we can do the sine inverse of -3/4, and that will tell us what angle we take the sine of to get -3/4. So we're going to do the sine inverse of -3/4. So now I got to open up my calculator, which if I was a good teacher who was prepared, I am. I was going to say a good teacher who's prepared, the calculator would be open. All right, so it is open. So I guess I am a good teacher who's prepared. All right, so now we're going to do the sine inverse. All right, so first keep in mind that we're answering in radians because the question asks for all angles between 0 and 2 pi. All right, 2 pi doesn't have the degree symbol, so we're assuming we're answering in radians. So if you have a TI Inspire, you go to the home screen, all right, open up a new doc and a new calculator. If you put the arrow over this gear, it'll tell you if you're in degrees or radians. All right, we're in degrees right now, so we want to change that. So we can click on that, go to document settings, and then change that to radians. And now we'll get our angle in radians. So now we have to do the sine inverse. So if you hit the trig button, you see sine, cos, tan in the reciprocals, and then below them are the inverse functions. We gotta do the sine inverse. Now remember, let's type in -3/4 for a second, but we have to keep in mind that sine inverse is only gonna give us angles, all right, between quadrants 1 and 4. So between 90 and -90, or pi over 2 and -pi over 2. All right, now this is not in terms of pi. It's just a radian, not in terms of pi, it's a decimal. So this would be the angle in quadrant 4, right? Which if you want to see what that is in degrees, we can multiply it by 180 over pi just to get a feel for how many degrees that is. All right, so that's about -48.5 degrees. All right, so our reference angle would be positive 48.5 degrees. But so in order to get the reference angle, what you want to do is the sine inverse of the positive angle. So of the positive ratio. So of +3/4. All right, if I hit Control Enter, I get the same angle but positive. All right, so I know that my angle in quadrant 1 is 0.848 radians. So we also have another angle in quadrant 2. So in degrees, if we want to convert this to degrees real quick, we can multiply by 180 over pi. All right, that's 48.59 degrees. So in quadrant 2, if it has a reference angle, 48.59 degrees, I would find the angle by doing 180 minus the reference angle, which gives me 131.41. Now, we can convert that back to radians by now taking that and multiplying it by pi over 180. All right, we get 2.29. Now, we didn't have to do that middle part, but we converted it to degrees. I just did that because I find that all my students are more familiar with degrees because that's what you work with in geometry and algebra. So we could have just done this step here, but in radians the whole time. Instead of doing 180 minus the reference angle, we could have done 180 as a radian, pi minus the reference angle, which was that. We get the same answer. So remember that when you do sine, cosine, tangent, inverse, you always want to do it of the positive ratio, like we did here. We did sine inverse of positive 3/4, because then that'll always give you the angle in quadrant 1, which is the reference angle. All right, so now we have that the angle that we would take the sine of to get 3/4 is either 0.84 or 2.29. Now, I actually made a mistake because we're not looking for the sine of an angle to give us 3/4. We want to do the sine of an angle that gives us negative 3/4. So what I want to do is take this reference angle and find the angles in quadrants 3 and 4. So now we're going to take this reference angle over here, I'll copy it, and do plus pi, because the rule for quadrant 3 is the reference angle plus 180 degrees. And for quadrant 4 would be 360 or 2 pi minus the reference angle, which was 0.848. That's enough rounding. All right, and we get 5.43. All right, so again, the sine of this angle will give us 3/4, negative 3/4, and the sine of this angle will also give us negative 3/4. Not exactly because I rounded, but it's close enough. All right, so now we have to finish the question. So remember, we were here. We had, if you want to scroll back in the video, you can see it. But we had the sine inverse of negative 3/4 is equal to, and I completely forgot what those numbers were. I should have read them both on my screen. Sorry, so we'll round it to 3.99 and 5.44. So 3.99 and 5.44. So the sine inverse of negative 3/4 is equal to 3.99 or 5.44. All right, so that's what x plus pi over 5 can equal. Because remember, we were originally solving for the sine of x plus pi over 5 is equal to negative 3/4. So to see what possible values we could take the sine of to get negative 3/4, we did the sine inverse of negative 3/4. So now we set it equal to the expression that was inside sine. All right, so now to solve for x, we're just going to subtract pi over 5 on both sides. So subtract pi over 5, subtract pi over 5. All right, subtract pi over 5, subtract pi over 5, and these are our answers. Now we got to use the calculator to see what they are as radians. And again, we don't have to put in terms of pi. We can leave them as decimal radians. So we'll take this angle and then subtract pi over 5. And then take this other angle and subtract pi over 5. Okay, and now if we look back to the original equation, we can check our work by plugging this back in. So we can do 4 times the sine of x, so here's one of our answers, plus pi over 5 minus 7, then we get negative 10. So that worked. All right, and then do the same thing. Plug in our other answer, which remember we rounded a little bit, so it might be off slightly. So like 4.8 will go. All right, and we also get a correct answer, which is off a little bit because I rounded this earlier. So just be more careful than I was. And both those answers are in between 0 and 2 pi because remember 2 pi is equal to 6.28. Now, one thing we could have done early on in the question is adjusted our range because, actually, never mind, that's it. We're good. So we got 2 answers between 0 and 2 pi. All right. Now you can also do this by graphing. You can if you could do something other than a scientific calculator, you can graph both sides and see where they intersect. So I meant to add a graph. So we can graph the left side 4 times the sine of x plus pi over 5. I'm going to put a multiplication symbol there. Minus 7. Okay, that shifts it down 7. And then graph negative 10. All right, and then remember that 2 pi is between like 0 and 2 pi, between 0 and 6.28. So that's 1, 2, 3, 4, 5, 6. So there's only 2 points that intersect on that interval. So we can do analyze graph intersection, go between the left and the right, and that's one of our answers that we got. And then do menu, analyze graph, intersect, and then that's the other point. So those are our 2 angles that we got earlier in radians, 3.36 and 4.81. I think I rounded to 4.80. All right, so that's number 1, and pretty much we got the sine part alone, then we did the inverse, and then we took the expression inside a sine and set it equal to the angles that we got. All right, and this would be a similar example. So, but now we want our answers between pi over 6 and 11 pi over 6. So let's try this one together. All right, so step 1, we're going to isolate that tan expression. So we're going to add 3 to both sides and divide by 3. So we got the tan of pi over 3x plus 3, 3 times that is equal to 3. And then we could divide both sides by 3. And we get the tan of pi over 3x plus 3 is equal to 1. All right, now we know that the tangent of 45 is equal to 1 degrees. So as a radian, we can make that pi over 4. Okay, we know that's equal to 1. And we also know that tangent is positive in quadrants 1 and 3. So also the tangent of 5 pi over 4 is equal to 1. But both of those are like what we would plug in here to make this true, not the values for x. So what we need to do is take this expression inside this trig function and set it equal to the possible angles that would make this equation true. So we have our first one, pi over 4. So we did pi x over 3 plus 3 is equal to pi over 4. Okay, so first I want to solve this and see if it's in this interval. All right, and that's the interval between 30 and looks like 330. So let's see. So if we subtract 3 on both sides, we get pi times x over 3 is equal to pi over 4 minus 3. All right, which we could just leave like that. Then we can multiply everything by 3 and get 3 pi over 4 minus 9, all right? And then we could divide everything by pi. All right, so let's see what that comes out as a decimal. So 3 pi over 4 minus 9 over pi. Whoops. 3 pi over 4 minus 9 over pi. So 3, another fraction here, 3 pi over 4 minus 9 all over pi. Okay, we get that, which as a decimal would be negative 2.1147, which is not in this range because pi over 6 would be, as a decimal, would be a positive 5.235, and 11 pi over 6 would be that. So let's try this again, but with the other angle that we found in quadrant 3. So instead of writing all that out, I could just do solve because I have a cast. So algebra solve, and I'm going to set the expression inside the tangent. So that's pi x over 3 plus 3 is equal to the other angle that we found. That would satisfy 3 times the tangent of theta minus 3 equals 0, which was 5 pi over 4, because that was an angle in quadrant 3 with a reference angle of 45 degrees. And I have to solve for x. I have to do comma x. And I get that angle, which, if I put it as a decimal, is 0.8852, which is, again, not in between. Oh, it is. It is in between. It's in between pi over 6 and 11 pi over 6. So that would be our answer. And we could see if we have another answer by doing the same thing, but instead of using pi over 4, using the angle coterminal to pi over 4, which would be pi over 4 plus 2 pi, or 45 plus 360, which would be 405. So as a radian, that would be 13 pi over 4, because that's 2 pi plus pi over 4. All right, and we get this angle is 6.88, which is not in this range between pi over 6 and 11 pi over 6. So our only answer is going to be this right here. All right, which was we got by setting this expression inside tangent equal to 5 pi over 4. All right. Now, these are a lot easier because you don't need a calculator for them, because you can evaluate these by using your memorized values. All right, so let's try these. So cosine of x is equal to root 3 over 2. All right, so you know that the cosine of 60 degrees is equal to root 3 over 2. So let's do this one in degrees. The next one we'll do in radians. So if we look ASTC, cosine is positive in quadrants 1 and quadrant 4. And we want to get a positive root 3 over 2. So we can use 60 degrees or 300 degrees. Now, it doesn't give us like a range, so we want to find all the angles that would make this true. So as degrees, we could do 60 plus every angle coterminal to it. So that would be like, you could just add multiples of 360. So we could do 60 plus 360k, where k is an integer. You could just write it out like that. Or another way you can express it for the other example. So 300 works, or any angle coterminal to it. So that'd be 300 plus 360k, And instead of writing k as an integer, you could use this symbol. This means belongs to, and this boldface Z means this set of integers. So literally these two things mean the same thing. It's just a matter, do you want to write out k as an integer, or do you want to use the symbols that makes it less writing? So k belongs to the set of integers, all right? Now, if you were asked to do that in radians, it's just divide everything by, or multiply everything by pi over 180. So this would become pi over 3 plus 2 pi k, and this would become 5 pi over 3 plus 2 pi k, and you would still do the same thing where k is an integer. So the red is your answer in degrees, the blue is your answer in radians. All right. And then last example I want to show you is if you have one of these funky ones where it's a reciprocal, then you could, if you're doing this without a calculator, just rewrite this as the cosine of 8x plus 4 pi over 3. So nothing about the input changes. But since like the secant of theta is equal to 1 over the cosine of theta, right? Notice how in our case, theta is 8x plus 4 pi over 3, right? That doesn't change, but the secant of theta is equal to 1 over cosine of theta means they're reciprocals. So the cosine of 8x plus 4 pi over 3 would equal 3 over 2 root 3. All right, which you might not recognize, but if you rationalize it, multiply the numerator and the denominator by root 3, you get 3 root 3 over 6, which is root 3 over 2. Okay, so we're in the same predicament here, where we know that the cosine of 60, or if we did it as radians, because this is 4 pi over 3, so we'll do everything in radians. We know the cosine of pi over 3 is equal to root 3 over 2. And we also know that the cosine of 5 pi over 3 is equal to root 3 over 2. And also every angle coterminal to that. Oops. So the way we set up this first part, let me rewrite that, 4 pi over 3, is we could take our possible answers that go here, which is every angle coterminal to pi over 3. So pi over 3 plus 2 pi k, and then set it equal to this input, 8x plus 4 pi over 3. And now we have to solve for x. So one thing you could do to make your life easier, get rid of these fractions, is to multiply everything by 3. So if we multiply both sides of the equation by 3, that'll help us get x alone. All right, we get pi plus 6 pi k. All right, remember, k is an integer, is equal to 24x plus 4 pi. All right, then we're trying to get x alone, so we can subtract 4 pi on both sides. So we get negative 3 pi plus 6 pi k is equal to 24x. All right, then we could just divide everything by 24. And this expression will give you the infinite amount of angles that you could plug in for x here and get a solution. So that simplifies to negative 3 pi over 24 would be negative pi over 8, plus 6 pi k over 24 would be pi k over 4. All right, and k is an integer. So no matter what k is, as long as it's an integer, you're going to get an expression here that makes this true. All right, and then you have to do all that over again for the other angle that we found, which was 5 pi over 3, right? Because the cosine of 60 the cosine of 60 is equal to root 3 over 2, and so is the cosine of 300. So you do the same process, but with a 5 there. So that would give us a 5 here. And then when you multiplied, that would give us a 5 there. And then that would make this just positive 1 pi. So I'm just, instead of writing it all out again, I'm just substituting in a 5 here and then solving it how it should look. And then that would be just positive 1 pi over 24. It wouldn't change the other thing. All right, and that would be our other solution. All right, so I threw a lot at you there, but pretty much for now, you want to get the trig function alone, then figure out what angles make that true by doing an inverse operation, and then set the expression inside the trig function equal to that angle, whether it's a specific angle or a set of infinite angles, and then solve for x. All right, and just a reminder, you could check your work. If you have a TI-inspired CAS, you could just do the solve function and it'll work. It won't find all the angles, but it'll find, oh, it might. Let's try it. So let's say if you have a TI-inspired CAS, you can go menu, algebra, solve, and then do secant of 8x plus 4 pi over 3 is equal to 2 root 3 over 3. And then remember, do comma x, so we're solving for x. And yeah, it does give you the infinite angles. So n1 would be the integer. All right, and I believe we're in degrees, so that would be our answer in degrees. So this is actually, we have to fix this because it doesn't make sense because it's expecting an answer in radians. So let's change that right now. Let's do radians. Okay, now let's do that again. All right, and that was similar answers that we got. And again, N2, N1 integers, right? We just got to distribute that. If you distribute the pi out, it looks like our answers. Or if you don't have a TI-inspired CAS, it's okay. You could plug your answers back in, or you can always graph both sides on a graphing calculator and see where they intersect. All right, and this will be a process. We'll add a little bit each day, but just try to focus on what was discussed here. And if you have questions, let me know. And then we'll add another layer every class.